Today we're going to be doing solving one-step equations, and you're on page 57 in your notebook. You're going to set up your notebook so that it looks just like this. This is your warm-up. Make sure that you read where it says use the order of operations to solve the following. So remember that your order of operations is parentheses, exponents, multiplication and division, addition and subtraction. That's PEMDAS. Please excuse my dear Aunt Sally. So make sure that you use that to solve your warm-up. Your learning goals is practice solving one-step equations involving addition, subtraction, multiplication, and division. And then your language goal, it says in writing, explain how to solve any equation. I can solve any equation by blank. This is your vocabulary words, inverse operation. So make sure that you write down this in your vocabulary section in your notebook. An inverse operation just means the opposite operations that undo each other, and we'll talk more about that. So solving equations is like undoing something. So let's practice with a few scenarios. So you want to tell me, how can I undo these things? And go ahead and write this in your notebook. So when I'm tying my shoes, in order for me to undo that step, well, that would mean to untie them. If I'm wrapping a present, the undo step would to unwrap the present. If I'm turning a light off, the undo step, or the opposite of that, would be turning the light on. And then the last one is closing a door. Well, the opposite of closing a door would be to open the door. So on this side it says adding 1/2. Well, the opposite of adding is subtracting, so the opposite of adding 1/2 would be subtracting 1/2. The next one says multiplying by -3. Well, I know the opposite of multiplication is division, so the opposite would be to divide by -3. And then it says dividing by 7.2. Well, again, I know the opposite of division will be multiplication, so I would need to multiply by 7.2. And then this last one, it says subtracting 8. And I know the opposite of subtraction is addition, so I would need to add 8. Alright, so inverse operations, the opposite operation, that's all that means. I want to do the opposite of what's going on. So list the operations and their inverse. Well, just like we just talked about in the last one, I know that the opposite of adding is subtracting. I know that the opposite of subtracting is adding. I know that the opposite of multiplying is dividing, and then I know the opposite of dividing is multiplication. If you can do that, then today should be fairly simple. You're going to need your example page out. It's that half sheet that's inside of your notebook, and you're going to want to be on example A. So example A says x plus 5 is equal to 11. So I want to do the inverse operation, or the opposite operation. Well, the opposite of addition would be subtraction. Okay, so I want to do a do and undo box for this. So you're going to label do and you're going to label undo. Well, the do step is the one that I have circled. That's what I started off with. That's that addition. I'm adding 5. In order for me to undo this step, I have to do the opposite of addition, which would be subtraction. And so I always want to use my undo steps. I always want to do the undo steps. So over here in the process box, this is where I'm going to show my work. So x plus 5 is equal to 11. So using my undo steps, I know that I have to subtract 5 on both sides of the equal sign. And I know 11 minus 5, that gives me 6. So I have x is equal to 6, but I have to check my answer. Really important that I check my answer. So all I have to do in my answer is I have the original equation, x plus 5 is equal to 11. So I'm going to plug this 6 in, my x value, into x. So now I have 6 plus 5 is equal to 11. So I need to check, is 6 plus 5 11? Well, 6 plus 5 is 11. So 11 is equal to 11, and that checks out. So I know that after I check my answer that I have the correct answer. So my solution is 6. If you go to example B, example B says x minus 7 is equal to 8. So the very first thing I want to do is I want to draw my do and undo boxes. We're going to be using these for 1 and 2 step equations. So right now in my situation I have minus 7. That's what's given in my equation. But I want to do the inverse operation, or the opposite operation. And the opposite of subtraction is addition. So I want to add 7. And remember, just like I said last time, we always want to use our undo steps in order for me to solve my problem. So I have x minus 7 is equal to 8. And since I only want to do my undo step, I have to add 7 to both sides. But sometimes I get confused about what both sides means. So I want to draw that line through the equal sign. And I want to add 7 to this side, and I want to add 7 to the other side. Negative 7 plus 7 gives me 0, so those cancel each other out. I'm left with x is equal to 8 plus 7, which gives me 15. But I need to double check. I have x is equal to 15, but I don't know if my answer is correct, so I need to check my answer. It is really important that you check your answer to make sure that you got the correct one. If you have the opportunity to check it, why not? So I have x minus 7 is equal to 8, and I want to plug in this 15 here into my x. So now I have 15 minus 7 is equal to 8. Well, I have to see what 15 minus 7 is. 5 minus 7, I can't do that, so I got to borrow. This comes to 15. 15 minus 7, I think that gives me 8. So 8 is equal to 8, and that checks out. Because those are both equal to each other, they're the same number, I can put a check mark next to it. If they were different numbers, then I would have to go back to see what I did in my process section. So my solution is 15. I did get the correct answer when I did that. If you flip your paper over, you have example C on the back. Example C says 6x is equal to 42. In order for me to solve this, I need to do an undo box. And right now, between this 6 and this x is a multiplication. Anytime I have a number next to a variable, it's multiplication, even if the sign is not there. So my do step, I'm multiplying by 6. In order for me to undo that, I need to divide by 6. And keeping in mind that we always use our undo steps to solve our problems. So I have 6x is equal to 42. Well, I need to divide that. So 6, I need to divide by 6. And then I need to divide on the other side of my equal sign by 6 as well. So I'm left with x is equal to 42 divided by 6 gives me 7. So I need to make sure if 7 is actually correct. So I rewrite my equation. 6x is equal to 42. In my x place, I'm going to put 7. So I have 6 times 7, which is equal to 42. Well, I know that 6 times 7 is actually 42. And so that checks out. They're both the same. So I can put that check mark there. You actually do have to work those out because it's not always going to be equal to each other if you solve the process wrong. So my solution, therefore, is 7. I knew that that checked out because I checked my answer. So example D, this is a fraction problem. It says x over 3 is equal to 27. So again, I'm going to need to draw those do and those undo boxes. And I have x over 3 is equal to 27. Well, right here I have a fraction, and I know that fraction also means division. So I'm dividing by 3 in my do step. That's what's happening right now in my equation. I'm doing x divided by 3. But my opposite of division would be multiplication, so I actually need to multiply by 3. Remember that I always use the undo step, and I only use the do step to tell me what I actually need to do, the steps to solve my problem. So I'm multiplying by 3 on both sides of that equal sign. Well, 3 over 1 times 1 over 3, those cancel each other out because 3 times 1 gives me 3 and 1 times 3 gives me 3, and 3 divided by 3 is 1, so those cancel. So I have x is equal to whatever 27 times 3 is, but I don't really know, so we have to figure that out. 3 times 7 is 21, 3 times 2 is 6, and 6 plus 2 is 8, so I get 81. But I have to check that out. So I have x divided by 3 is equal to 27. And so I want to plug in that 81 that I got into that x. So now I have 81 divided by 3 is equal to 27. I don't know off the top of my head what 81 divided by 3 is. So I actually have to work that out. 81 divided by 3. Well, I know 3 goes into 8 2 times. 3 times 2 gives me 6. 8 minus 6 is 2. I bring down my 1. 3 goes into 21 7 times. So now that I've worked that out, I know that 27 is actually equal to that 27, and so I can check that off. So therefore my solution is 81. What I need you to do is I need you to take out that practice page, and I want you to solve all 8 of those problems. Make sure that your name is on it, and you're going to turn it in. Please don't forget to glue in your notes. It's a front and back, so you're going to need to make a tab so that you can see front and back once you glue those in. Please raise your hand if you have any questions, but refer back to your notes before you ask any of those questions.